Good evening, everyone. Myself Gautam sir. I welcome you to the Sapience Education. So today I am going to discuss about the moving charges and magnetism, and this is part one video. So by sequence, one by one, I will discuss each and every topic. So this is totally based on the 12th book as per the new syllabus. Okay. So let us start from here. What is actually the magnetic field? Okay. The magnetic field is a space around the conductor carrying a current, or the space around which the magnetic effect can be felt. For example, this is your magnet, right? This is your magnet, okay? Or we can say that this is a current carrying conductor. The area where other metal will get attracted or repulsion, the area around the wire at which the magnetic effect can be felt is known as magnetic field. Magnetic field is a vector quantity and it is denoted by the B. Okay, so it is denoted by the B. It is denoted by B. Again, is your force on a moving charge in a magnetic field. What do you mean by this? See, let us consider if there is a magnetic field, right? And if a charge is moving, so what will happen? There will be an extra external force which will be applied on this, and this force is known as this force will be there. Consider a positive charge Q moving in a uniform magnetic field with the velocity v. See here, this is a positive charge and it is moving with the angle of theta with the magnetic field. Okay, so what will happen? It will experience a force on the above. Okay, we have, as per this, we have seen that if charge is high, so force will be high. It means that force is directly proportional to the charge q. Directly proportional to the charge q. And another thing is that force is also proportional to the b cos theta. As soon as b cos theta will be more, so force will be more. So sorry, b sin theta. Why b sin theta? See here, because when when the when the when any charge will be parallel, when any charge will be parallel to it, so what happen? Force will be zero. So see here, when charge its component velocity component is in this direction, so due to this what happen? Force will become zero. But the velocity component in this direction, the force won't be zero, right? So what we can say that force is equal to force, the velocity component, due to sin theta only, force will increase. So from here we can say that force is directly proportional to b sin theta. Also, force is directly proportional to b. That is magnetic. See here, force is directly proportional to b. Okay. So b means what? If you increase the magnetic field, so force on the charge will also increase. So finally, we have got the equation here. Force is directly proportional to charge. Force acting on directly proportional to b sin theta only. We can't say b cos theta. Why? Because b cos theta is parallel to the magnetic field. So when any charge is moving parallel to the magnetic field, so what will happen? Force won't be act. So here we can say that force won't act. So by combining these three above equations, so we are getting F is proportional to QP B sin theta. Okay, so when remove proportionality constant, so there will be, let us suppose K is the proportionality constant like this. We can write here F is equal to K QB B sin theta. But the value of K has been taken as 1. So from here we have F is equal to QB B sin theta, right? So finally force is equal to Q B, because B has a direction, magnetic field has a direction, but charge does not have a direction. So can we say that force is equal to Q B cross B? Why? Because both are vector quantities. So while cross product each other, so what will happen? BB sin theta will happen. So finally we have got the force on a charge. Force on a charge when moving in a magnetic field. So finally we have got the derivation, force on moving charge in a magnetic field, right? So this is how we can derive it. So I hope you have understood now. Now the direction of the force is in the direction of the cross product of the B. Why? Because we have taken B cross B. So let us consider this is the magnetic field B, and let us consider this is the velocity direction B. When you cross B cross B, so what will happen? The direction will be perpendicular to both. So the force direction, the cross product of the velocity B and magnetic field B, which is perpendicular to the plane containing BB. See, let us consider the plane. This is a plane, and this in this direction there is a magnetic field. In this direction there is a velocity vector. So the force direction will be in this. Always, force will always be perpendicular to both, either magnetic field as well as velocity. Right? So see here. This is a magnetic field, this is velocity b, and this is theta. So we have to use right hand thumb rule so that you can get the direction of the force. Now if if this is positive charge, q is positive, but if you take q as negative, so what will happen? It will be negative of b cross b. Negative of b cross b means what? Negative of b cross b can be written as b cross b. See, negative of b cross b means q into b cross, right? So this is the force direction, right? So I hope you have understood this. SI unit of B is Tesla, that is Weber per meter square. Okay. SI unit of B is Weber. SI unit of the B is Tesla. Tesla. So magnetic field B as SI unit as a Tesla. And you can use right hand screw. This is right. This is right hand screw rule. Okay. So I hope you have understood this. Now, what is Tesla? Tesla is the unit of magnetic field. The magnetic field at a point is said to be 1 Tesla if a charge of 1 coulomb while moving at a right angle to the magnetic field. The velocity of 1 meter per second experiences a force of 1 Newton at that point. See, we have already got F is equal to QV base. We can write here F is equal to QV sine theta, right? Now from here we can say that B is equal to F by QV sine theta. Now what happens? See here, when the magnetic field B is there, and if a 1 coulomb of charge is equal to 1 coulomb is moving with 1 meter per second, then the amount of force experienced is 1 Newton. Then the field is known as 1 Tesla. So 1 Tesla is the amount of a magnetic field in which force will become 1 Newton. Charge we can move in 1 coulomb and the speed should be 1 meter per second is. So finally, magnetic field B is equal to 1 is right. I hope you have understood this. Now magnetic force on the current carrying conductor. Since see here, consider a wire of a uniform cross section, right? See here. See, this is the wire having an area A and drift velocity D. What is about drift velocity? Drift velocity is the